This is SpaceTime, Series 24, Episode 18. Coming up on SpaceTime, a new planet discovered in the habitable zone around Alpha Centauri, confirmation of what, for now at least, is the solar system's most distant planetary object, and what the moon Phobos could reveal about the red planet Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers may have discovered another planet in our nearest neighbouring star system, Alpha Centauri. Initial observations using the European Southern Observatory's Very Large Telescope, or VLT, in Chile, have detected what could be a sub-Neptune-sized world orbiting in the habitable zone around Alpha Centauri A, the largest star in the system. A report in the journal Nature Communications says the potential planet appears to be about 3 times the size of the Earth and has been designated C1 for Planetary Candidate 1. Located some 4.37 light-years away, Alva Centauri is seen in the southern night skies as the more distant of the 2 pointer stars from the Southern Cross. The system consists of 3 stars. There's Alpha Centauri A and B, which orbit each other, and Proxima Centauri, which orbit the pair, and at 4.25 light-years distant, is currently the closest star to the Earth other than the Sun. Like the Sun, Alpha Centauri A is a spectrotype G yellow dwarf star. It's about 10% more massive than the Sun and around 50% more luminous. Its binary partner, Alpha Centauri B, is a spectrotype K orange dwarf star, a little smaller and cooler than the Sun, with about 90% of the Sun's mass and about half its luminosity. Alpha Centauri A and B orbit each other around a common centre of gravity every 79.91 Earth years at between 11.2 and 35.6 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres or 8.3 light minutes. The distance between the 2 stars varies from about that between Pluto and the Sun and Saturn and the Sun. The 3rd star in the system is Proxima Centauri. It's a spectrotype M red dwarf star with about 1/7 the diameter and about 1/8 the mass of the Sun. It's loosely gravitationally bound to Alpha Centauri A and B, orbiting the pair at an average distance of around 13,000 astronomical units, or about 0.21 light-years. To put that another way, it's about 430 times the size of Neptune's orbit around the Sun. It takes Proxima Centauri approximately 550,000 years to orbit Alpha Centauri A and B. In 2016, astronomers confirmed the existence of an Earth-sized terrestrial planet orbiting in the habitable zone around Proxima Centauri, making it the nearest known extrasolar or exoplanet to Earth. The planet, known as Proxima b, is a super-Earth with about 1.3 times Earth's mass. It orbits Proxima Centauri at an average distance of just 0.05 astronomical units. That's about 7.5 million kilometres. And because Proxima Centauri is a red dwarf, that happens to be in the star's habitable zone, the region around a star where temperatures would allow liquid water, essential for life as we know it, to pool on a terrestrial planet's surface. Proxima b takes just 11 Earth days to complete one orbit around its host star. That's far closer than Mercury's 88 Earth day orbit around the Sun. Then in 2020, astronomers combined several independent measurements to confirm the existence of a second planet around Proxima Centauri. The new planet, Proxima c, has about 7 times the mass of Earth and circles its host star at a distance of 1.5 astronomical units, with an orbital period of 1,907 Earth days. And now there's Alpha Centauri A's new planetary candidate 1. It was detected using a newly developed mid-infrared chronograph exoplanet imaging system, developed by the European Southern Observatory and physicist Yuri Milner's Breakthrough Watch initiative. It allows astronomers to directly capture images of exoplanets about 3 times the size of the Earth within the habitable zone of nearby stars by blocking out most of the light coming from that star. And it's optimized to capture infrared wavelength signatures emitted by the warm surface of an orbiting planet. And now, with the discovery made, the real work begins trying to confirm it. This is SpaceTime. Still to come, confirmation of what could be the solar system's most distant planetary object, and what the moon Phobos could tell us about the red planet Mars. All that and more coming up on SpaceTime. Astronomers may have just set a new record for identifying what looks like the most distant body in our solar system. The object, officially designated as 2018 AG37 and unofficially named Far Far Out, is orbiting the Sun at a distance of 19.8 billion kilometres. That's some 4 times further out than Pluto, and about 132 astronomical units. It's well beyond the heliopause, the theoretical boundary where the Sun's solar wind is stopped by the interstellar medium due to stellar winds from surrounding stars. At 121.5 astronomical units, that's been the officially designated boundary of our solar system. And once the Voyagers 1 and 2 spacecraft passed that point, both were considered to have left the solar system and were flying through interstellar space. Initial estimates suggest that Far Far Out, it's a great name, isn't it, is about 400 kilometres wide. It was first detected in 2018, and scientists have now collected enough observations to pin down at least part of its orbit. Far Far Out's name clearly distinguishes it from the previous record holder, Far Out, which was found by the same team of astronomers also in 2018. The newly discovered object has a highly elongated orbit, ranging from as much as 175 astronomical units down to around 27 astronomical units, which is just inside the orbit of Neptune around the Sun. Far Far Out's journey around the Sun is estimated to take around 1,000 years, crossing Neptune's orbit every time. And that means that Far Far Out's probably experienced some strong gravitational interactions with Neptune over the age of the solar system, and it could be the reason why it has such an elongated orbit. Far Far Out was discovered by the 8-metre Subaru telescope atop of Mauna Kea in Hawaii, with additional observations made using the Gemini North and Magellan telescopes in order to better define its orbit based on its slow motion across the sky. This is SpaceTime. Still to come, what the moon Phobos could reveal about the red planet Mars, and a new sky guide for astronomy buffs in the southern hemisphere. All that and more still to come on SpaceTime. A new study has found that the Martian moon Phobos orbits through a stream of charged particles being eroded from the red planet's atmosphere by the solar wind. The findings, based on data from NASA's Mars Atmosphere and Volatile Evolution or MAVEN spacecraft, suggest that these particles could be building up on Phobos' surface, thereby providing a record of the past Martian atmosphere. MAVEN's orbit crosses Phobos' orbit around 5 times a day, and its Suprathermal and Thermal Ion Composition Instrument, or STATIC, measures Martian ions in Phobos' environment. STATIC measures the kinetic energy and velocity of incoming particles, thereby allowing astronomers to determine their mass and consequently what types of particles they are. Astronomers have identified charged particles including ions of oxygen, carbon, nitrogen and argon, which have been escaping the Martian atmosphere for billions of years. A report in the journal Nature Geoscience suggests that if the regolith from Phobos were analysed in labs on Earth, it could reveal key information about the evolution of the Martian atmosphere. See, today Mars is a freeze-dried desert with less than 1% of the atmospheric density of the Earth. But roll the clock back 4 billion years, and the red planet was a warm, wet world with a thick atmosphere, one capable of supporting life. Phobos is the larger of the 2 moons orbiting Mars. The other is Deimos. The origin of the 2 Martian moons remains a topic of great debate among astronomers, with the hypothesis that they both captured asteroids being the leading contender for now. Just 22 kilometres wide, Phobos orbits the red planet at a distance of just 6,000 kilometres. And like the Earth's moon, Phobos is tidally locked to Mars, with the same side always facing the planet. So the regolith on the near side of Phobos has been bathed for millennia in Martian atoms and molecules. The data from MAVEN suggests that between 20 and 100 times more Martian ions would have coated the near side of the moon compared to the far side. That makes it a potentially rich scientific harvest, which the Japan Aerospace Exploration Agency JAXA hopes to secure with its upcoming MMX, or Mars Moons Exploration Sample Return mission. MMX is slated for launch in 2024. Collecting a drill core sample of Phobos' regolith would allow astronomers to see how the Martian atmosphere and its climate have evolved. And it would also help resolve that question about the true origins of Phobos as well. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
What was Mars like before its atmosphere was kind of, unable to hold its integrity? I think that would be the best way to describe it.
Yeah, the most highly supported view is that there was a time in Mars's distant past, probably 3.8 to 4 billion years ago, when its atmosphere was essentially warm and wet, very like the Earth's atmosphere, with an average temperature of about 15 degrees Celsius over the whole planet, with plenty of moisture in the air and on the ground, because the overwhelming evidence is that Mars had river flows, it had lakes, it had seas probably. The northern hemisphere is very flat and very smooth, which suggests that there was a large body of water there sometime in the past. The only thing that's changed that view is the idea that maybe Mars, some of these water features could have been formed underneath huge glaciers, so that you've got this sort of almost like snowball Mars, but with the rivers made of meltwater effectively flowing underneath these glacial sheets. So that's a slightly new idea. It's got some support, but I think the overwhelming view is still that at some time, even if it might have been only for brief periods, Mars had a warm and wet climate. The trouble is, how do you probe back into Mars's climate? And that's where the story begins. Because there is
Have they been able to do so, or are they looking at ways of doing so?
Yeah, it's a future possibility, but one that's really intriguing, and with good reason to believe that this will be a very successful venture when it finally gets going. So we know from a spacecraft that's already in orbit around Mars, it's called MAVEN or MAVEN. Somewhere I've got the acronym, which is Mars Atmosphere and Volatile Evolution. There you are. You've got to stick the N on the end from evolution, but Mars Atmosphere and Volatile Evolution, what it means is it's sensing the upper atmosphere of Mars. It's been there for 6 years, actually, collecting data. But one of the things that MAVEN has uncovered is that there is a flow of actually charged particles, what we call ions in science, IONS, which are particles that have lost some of their electrons. And these particles of oxygen, carbon, nitrogen, argon, these have been coming off the surface of Mars for billions of years, and MAVEN has detected them. I've seen results from those detections, which are really interesting. But I guess what's new, and this is the work that we're talking about today, it's actually come from University of California, Berkeley, and other institutions. What's new is the recognition that those ions, those charged particles, have found their way not just into space, but also onto the surface of Mars's largest moon, or larger moon, there are only two, which is Phobos. Phobos, an object 30, 40 kilometres across. Really interesting in its own right, because it's got a very low density. It's probably something a bit like pumice in its makeup, and space scientists are not that sure where it came from and how it got to be like it is. But the bottom line is that Phobos is in the flow of these ions, and they will essentially deposit on the surface of Phobos, which is not subject to any other kind of phenomena apart from radiation from the sun, which is well understood and you can deal with that. So the suggestion that has been made is that if a future spacecraft could go to Phobos and collect samples from its surface and then bring them back, they might tell us not only about the origin of Phobos, but the material that's come from Mars, particularly if, and this is the crux of the mission, if you landed the spacecraft on the side of Phobos that always faces Mars, because Phobos is like the moon. It always has the same face to its parent planet. It's tidally locked, exactly. In fact, it's even more tidally locked than the moon, because Phobos is actually 60 times closer to Mars than the moon is to the Earth. It's very, very close. It actually whizzes round. One of the curious things about Phobos is its orbital period is so short, and I can't remember, it's a matter of hours, but it's so short that Phobos rises in the west and sets in the east, which must be quite entertaining to watch. Most other things do things the other way around. Anyway, if you send a space probe to land on the Mars-facing side of Phobos and bring back samples, it is just possible that what you might get is a timeline history of the atmosphere of Mars, which might tell us what the atmosphere was like in these ages ago, these times 3.8 or 4 billion years ago, when Mars is thought to have been warm and wet. Now, the good news to this story is that there is already a spacecraft planned to do that.
I was going to ask you.
Yeah, JAXA, the Japan Aerospace Exploration Agency, they have something called MMX. MMX is a kind of acronym for Martian Moons Exploration, and it's a probe that's going to Phobos, and the intention is that it will collect samples from its surface and bring them back to Earth. The Japanese are very good at that. They've done it twice with asteroid samples. We've seen the most recent one landing in Australia at the end of 2020 from the Hayabusa 2 spacecraft. So it's a mission with a high chance of success and would be very, very interesting. It would be brilliant if we could just sort of open a book, an archive of the past atmosphere of Mars that says, yes, back in 3.8 billion years, before the Common Era, Mars had this climate, this particular level of carbon dioxide in the atmosphere. That's basically what you're looking for, because that would be what kept Mars warm. So, yeah, it's a fantastic possibility.
I suppose what mystifies me to a certain degree is how it was that Mars was able to maintain for some period of time a wet, warm environment.
Yeah.
And then it couldn't. I mean, what changed, or was it just, it was always destined to fail?
It was, because it's too small to hold on to a thick atmosphere. So there's actually another aspect to it as well, and that's that it doesn't have a magnetic field. But these are the two factors. They come about because Mars is small. It's smaller than the Earth by a factor of 2, so its diameter is half the diameter of the Earth. That means its core would have cooled much more rapidly than the Earth's core has done. That means that there would be no chance of supporting plate tectonics, which is one of the crucial things that stabilizes our atmosphere, in fact, and it would have stabilized Mars's atmosphere. Plate tectonics are driven by internal heat. There is some evidence from sort of residual magnetic fields on Mars here and there that look as though they might have been formed around the boundaries of continental plates, but they must have solidified a very, very long time ago, because we believe that Mars's crust is now sort of continuous, like an orange peel. And we believe it's been like that for a long time, because that's the explanation as to how Mars's volcanoes grew so big, in particular Olympus Mons, the biggest volcano in the solar system. It's because there was no plate tectonics shuffling it around over the mantle hotspot that was driving it, as the Hawaiian Islands have done. They've moved around above the hotspot, so you've got this chain of islands. There's still, Mauna Kea is still, the biggest mountain in the world when you reckon it from the sea floor.
Yes, exactly.
But it's nothing like Olympus Mons. And Olympus Mons is thought to have got to that size because there is no plate tectonics. So plate tectonics is one of the things that stabilizes the carbon in an atmosphere. And if you get rid of that, then you've got this risk of losing the atmosphere to space, plus the fact that, as I said, Mars does not have a magnetic field, so it doesn't have a magnetosphere protecting it from the radiation of the sun. And that too is a driver for the evaporation of an atmosphere. So it probably lost its warm, wet atmosphere quite early on in the piece. But the trick is to go to Mars with MMX and find out. Maybe we will.
Yeah. So it would have developed that warm, wet atmosphere while it had a continental tectonics and a warm interior. But as that cooled off and everything sort of set in stone, literally, it was doomed.
Yeah. It's doomed. That's right. Yes.
Well, that's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. Still to come, the 2021 Australasian Sky Guide's been released, providing its annual tour across the night skies. And later in the Science Report, a new study finds that people hospitalised with COVID-19 are still likely to show some symptoms 4 months later. All that and much more still to come on Space Time. The 2021 Australasian Sky Guide's been released, providing its annual tour across the night skies. Unlike most astronomical guides, this one observes the celestial sphere from the southern hemisphere's perspective. The guide is written by astronomer and Powerhouse Museum Sydney Observatory consultant Dr. Nick Lom, and it contains details of this year's celestial events, complete with monthly sky maps, astronomical explanations, viewing tips, and historical features. This year's highlights include supermoons in April and May, a partial lunar eclipse in November, and a partial solar eclipse in December.
The Sky Guide for current year is out and available. It is the 31st edition, so it's been going since 1991. It has a spectacular cover of the comet, Comet 1, green-coloured comet. Every year the cover photo is selected from ones that have been submitted for the David Merlin Award, and which is run by the Central West Astronomical Society every year. And this one is a very spectacular photo of Comet Swan taken by Ross Giacomato. There are lots of highlights during the year, astronomical highlights in the year, which are covered in the Sky Guide. The main ones are 2 eclipses of the moon. First one on 26th of May is a total eclipse. These are, of course, always very spectacular to watch. Then the moon turns a red colour. Occasionally some media call it a blood moon, but that's probably going a little bit too far, but there's certainly a definite red colour, and it's very spectacular, easy and safe to look at, and also photograph. And what's also interesting about that first total eclipse of the moon in May is that the moon is near perigee, so that's referred to as a supermoon, and so people can watch the moon rise, a slightly larger moon than usual, rising around 5 in the afternoon as the sun sets. And a few hours later, 3 hours later, the eclipse begins. So it will be a very spectacular night. Near the end of the year, in November, there will be a partial eclipse of the moon. But this is interesting because it's almost total. It's 98% total. So again, the moon is most likely to turn a red colour. And what's also spectacular, it will rising partially eclipse. So this, on the partially lit moon, some of it with a bit of a red colour will be rising in the eastern sky. And again, it's safe and interesting to look at, and also could give rise to spectacular photos. I should say that when trying to photograph anything in the sky, especially anything at night, the important thing is to keep the camera steady. These days, most of us have mobile phones with very good cameras and improving all the time, but the important thing is to take the photo and keep the camera on the phone very steady. There are 2 main meteor showers in the year, as there are every year. Fortunately, this year, both showers are favourable in the sense that the moon will not be brightening the sky during the meteor showers. The first one is in May, early May, the Aquarid. This is associated with Halley's Comet, and occurs as usual with a meteor shower in the early morning. There is a moon in the sky, but it's a waning crescent, so it's only a crescent moon. It's not going to brighten the sky very much, so it is worth looking out for the shower in the early morning. Best to be in a dark spot, away from as many lights as possible. And the moon, as I shouldn't be brightening the sky too much, but it will actually make the sky look more interesting, having this crescent moon in the sky. The other major meteor shower in the year is the Hegemony, and that occurs in mid-December. The moon at that stage is fairly bright, that it's between first quarter and full moon, but however, it's set a couple of hours before dawn. So there'll be a very nice window of the sky just before dawn when it will be visible, and the shower will be visible without the moon brightening the sky. And once again, it's best to try and find a spot away from bright lights. The darker the place, the more chances of seeing meteors. There's also a partial solar eclipse in the year. This is in early December. It's only visible from a couple of places though, from Hobart and Melbourne. Hobart, it's only 21% of the sun will be covered by, during the eclipse, covered by the moon, while in Melbourne, only 7%. So they're worth looking at, but of course, when looking at the sun, extreme care has to be taken. The right filters have to be used for projection, either pinhole projection, so it staples back to the sun, holding up a piece of cardboard with a hole in it, and projecting the image onto another piece of cardboard. So it's worth looking at as long as people live in Hobart and Melbourne. There are some interesting configurations of the planet during the year. One that I like is in middle of July. Mars and Venus are going to be very close in the sky, and the crescent moon will be nearby. So it will be an interesting configuration with the two planets close together and the crescent moon. Once again, it's a good opportunity for photography. So this time people would have to zoom up, I would imagine, to get a good photo. Every year there's a section in the Sky Guide on anniversaries. This year there's a very interesting anniversary, 150th anniversary of an expedition to see a total eclipse of the Sun from Cape York. Back in 1871, when this eclipse took place, December 1871, there were no roads. It was actually very difficult to get up to Northern Australia, where this eclipse was visible. So the best way to get up there was by ship, and the major expedition was mounted. It was begun by the Royal Society of Victoria, but involved cooperation between the different governments, between different colonial governments, and that was very rare in those days. The South Australian government, New South Wales government, Victorian government, Queensland government, and so actually that was very important, active early cooperation between the states, all helping to organise this expedition. The expedition is also notable because this was the first expedition to see a total eclipse of the Sun after the development of photography and also the application of spectroscopy. Photography, of course, let us record what we see instead of just looking by eye, which is much more useful. Spectroscopy is a way of dividing light into components and actually working out what you're looking at. So people were very interested in looking at the corona of the Sun, the outer atmosphere of the Sun that's only visible during a total eclipse of the Sun. Now, unfortunately, the expedition went up to Cape York. They set up on an island just off Cape York, which they named Eclipse Island. Today it's named Morris Island. And unfortunately, it was cloudy, which is
Oh, what a bummer.
What happens. With astronomers often find that whatever they want to look at, if it's something really interesting in the sky, then it's cloudy. And unfortunately, it was on that occasion. So the astronomers were not happy, but there were other scientists, especially naturalists, on the expedition, and they were very happy. They collected lots of plants, interesting animals, which they brought back. So the naturalists were happy. One of their number was what is interested in shells, and he discovered a whole number of animals with shells, and he named them after some of the leading astronomers on board. So there's a lot on the Sky Guide. On the highlight, there are monthly maps showing what's up in the sky. There's monthly maps showing the configuration of the planets or anything interesting that's happening during the year. And there's a lot of updates to the solar system, the planets in the solar system. For example, the planet Saturn during last year had its number of moons increased by 20. Used to have 62 moons, now has 82. So it has leapfrogged Jupiter.
Jupiter must be upset.
Yeah, you would imagine. So Jupiter is 79. So at this stage, Saturn can boast 3 more moons than Jupiter.
It's always an interesting demarcation. When do you call it a moon and when do you call it a big rock in a ring around the planet?
Yeah, I would imagine that's a difficult choice, but hopefully these 20 are big enough to be definitely called moons around Saturn.
This year's Sky Guide also has a look at the history of eclipses among Aboriginal people.
That's correct. That's also a feature of the Sky Guide every year to have some input or insight into Aboriginal astronomy, and they're very interesting stories about Aboriginal ideas of eclipses.
Where do you get the Sky Guide?
You can get it from many places, obviously from Sydney Observatory, from the Powerhouse Museum in Sydney. It's available from bookshops. If they don't have it, they can order it in, or it's available online, again, from the Powerhouse Museum. And it's available as an e-book as well, so people can have a physical book at home and carry around the e-book version on their mobiles. So it's available from Amazon as an Amazon Kindle e-book or from Apple Book.
That's Dr. Nick Lom from the Powerhouse Museum, Sydney Observatory. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that people who survived being hospitalised with COVID-19 still showed symptoms some 4 months later. The study of 238 patients found that 53% still had some sort of functional impairment after 4 months. The findings, reported in the Journal of the American Medical Association, show that many patients experienced respiratory impairments and reduced ability to exercise, while around 1 in 6 had post-traumatic stress symptoms. Some 2.4 million people have now died from COVID-19, with another 108 million people having been infected since the virus first emerged from its Wuhan, China epicenter in November 2019. Meanwhile, a new study has confirmed that the more packets of cigarettes you smoke over a lifetime, the higher your risk of being hospitalised or dying from COVID-19. Previous studies linking smoking to COVID-19 risk have been limited and often contradictory. But the new findings, reported in the Journal of the American Medical Association, show that the greater your exposure to cigarette smoke was an independent risk factor for hospital admission and death from COVID-19. Scientists with the Australian National University have set a new world record for solar cell efficiency. The researchers developed a perovskite solar cell that can achieve 21.6% efficiency in converting sunlight into electricity. And that's a new record for a perovskite solar cell larger than 1 square centimetre in size. A report in the journal Science claims the team used a special group of materials which were both inexpensive and easy to manufacture. Scientists have discovered 3 new species of carnivorous sponges in the deep waters off the Great Australian Bight. A report in the journal Zootaxa claims the sponges were found in 3 kilometres of water. The new species, described by scientists from the Queensland Museum, are the first recorded carnivorous species from South Australia, and they boost the overall number of sponge species found in Australia to 25. Well, like most kids growing up in Australia, I live to go skateboarding and surfing after school and on weekends. So, normally when I think of the beach being dead, it means the sets aren't breaking the way they should, not that the beach is haunted. But apparently, a group with clearly way too much time on their hands has come up with a list of what they claim are Australia's most haunted beaches. Tim Mindham from Australian Skeptics has the story.
Well, interestingly, one of the beaches that is referred to was right near where I used to live, and I used to visit it surreptitiously because at the time it was part of the quarantine station at North Head in Sydney.
Right.
Yes, and that was supposed to be off limits. But if you walked around the rocks, you could get to the beach and there'd be no one there, no dead bodies, nothing particularly. But of course, it's the buildings that are in the whole quarantine station that are supposed to be haunted. And I visited them for a ghost walk too, and actually I walked away for a bit and then started walking back, and I scared the hell out of everybody. They thought I was the ghost. And I think I'm not exactly the smallest person to be sort of transparent. But there's a whole range of beaches, and if your listeners want to know, there's beaches in New South Wales, South Australia, and Western Australia, and some of them are supposed to have bodies and floating body parts and mauled swimmers and all this sort of stuff and screaming and the usual sort of thing. But for the record, at Brighton Beach in South Australia, out near Adelaide, it's also Bunker Bay in WA, Manly Beach, and this is the whole Manly Beach. This is not the quarantine station. This is the whole of Manly Beach.
North Stain, South Stain, the lot.
That's right. Would you think it's during the summertime? It's pretty busy outside of coronavirus restrictions, but even then, I think people would have recognised the ghost or seen it more often than not. And the quarantine station is actually what they're referring to by and large. Minamurra Beach in New South Wales, and that's about it. Apparently, that's the list of those haunted beaches. The quarantine station at least has buildings on it. Most of the rest are beaches. You think?
Yes, but Manly Beach has the Corso and the pub right next to it. So
that's right. Yeah,
you're going to have bodies lying on the beach after midnight anyway. The spirits are alcoholic, not ghost.
Very good. Yes, you walk across from the pub across to the beach, and there you are.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.